Hello, everyone. My name is Snehal Desai. Um, just quickly going over this one medication here on Lomitapide. Um, some of you may have already seen in Pharmacy Times Journal about a recent approval for Lomitapide, and essentially, um, what it is basically to help those who have this genetic condition on homozygous familial hypocholesterolemia, and essentially, um, so it's like an anti-hyperlipidemic agent, or like a cholesterol medication to for those with that kind of condition, where it's not um, where the LDL receptors are just not working properly in collecting the LDL particles from the blood. So there will be an increase in the LDL levels in those type of patients. So there is a medication out here to treat um, this condition, and I'm going to show you a mechanistic preview of how this medication works so you all can see it. But before we start, I wanted to share a little bit about this genetic condition. So what happens here is in the blood system, you have like cholesterol. And cholesterol is essentially very important, especially for the structural functionality of a cell, any of the cells in the body. Um, and so whenever particles are running through in the body, one of the enzymes that's needed, or one of the protein particles that's needed, is the apolipoprotein B100. And um, they also run throughout the blood as well when it's combined with the cholesterol particle. So our livers usually make this particle and is basically packaged through the or made in the made or formed by the endoplasmic reticulum of the liver cell, and then um, in the process, there's another protein out there that helps kind of package these particles together to form VLDL, um, which then, as a result, converts into LDL and goes into our bloodstream. So what happens here is in the liver, you have a ApoB protein, okay, and within it, it's formed by the hepatocytes or the liver cells, and then MTP kind of uses to transport like triglycerides. Um, I'll just say TG, or like cholesterol, other cholesterol esters or particles, and as a result, it kind of puts together and assembles the VLDL particle. And then VLDL goes outside the liver into a blood, and then eventually gets broken down into LDL. Now that LDL contains the apolipoprotein protein that's converted by VLDL to LDL. So apolipoB protein is actually followed and packaged inside that LDL particle, and then it actually goes right out to the blood. And then usually, whenever the um, cells need some cholesterol or something, the receptors are going to be out there on the liver, and those LDLR receptors would collect that LDL particle and then break it down and then form free cholesterol, which is released for the cell's needs. However, whenever there is condition like this, homozygous familial hypercholesterolemia, excuse my pronunciation here, it may result in it basically um, results in a mutation of this LDLR receptor. And what that is, it's either the receptor is going to be reduced or it's just not going to function properly. It's not going to recognize the apolipoB protein of the LDL particle to take it in and then do the normal functioning and then break it down into free cholesterol for cells to use. So um, there is a medication out there that can kind of prevent that, and it's actually this medication, Lomitapide, and it actually inhibits the MTP process. You can see here inhibition of the MTP. MTP is how the formation of the VLDL occurs, and so it prevents that formation of the VLDL so it doesn't get converted into LDL eventually. And so it's just a way of using it to help lower um, the lower the bad cholesterol levels in the blood. So that's essentially what it is. And if you have any other questions, please feel free to let me know. Thank you for watching.